Hello everyone, I am Professor Amit Vyas, Computer IT Department from Dr. Subhash Technical Campus. Today we are discuss about the topic is interrupt cycle. So what is the interrupt cycle? Now the next is first of all we are show about types of interrupt. So here we can show that three types of interrupt. First is external interrupt, second is internal interrupt, third is software interrupt. So we can show that external interrupt is come from input output device, from time device for power supply, or from any other sources. For example, IO device request to transfer the data, IO device finish the transfer of data, or power failure. So what is the external device? If the one example, if the power we can fail, then data transfer we can stop. So we can show the external interrupt. So not come from the computer. So this is called the external interrupt. So now the next is internal interrupt. Internal interrupt is arise from illegal or erroneous use of instruction or a data. For example, internal interrupt are error condition, divide by zero, stack overflow, invalid operation code, or many more error-based conditions. So what is the internal interrupt? If any condition is divided by zero, then process is occupy some internal interrupt. Or any stack overflow or any invalid operation is occupied. That time you can use or arise internal interrupt. So the next is software interrupt. The most common use of software interrupt is associated with a supervisor call of instruction. It means certain operation is computer may be assigned to the supervisor mode of only. For example, complex input and output procedure. It means so some operation is occupy only supervision mode of operation. It means some computer we can assign some specific operation in particular code. So this is called the software interrupt. Now the next is interrupt cycle. So what is the interrupt cycle? How can you execute and how can you solve the problems? We can show that here the flow chart of interrupt cycle. Now we can show one short explanation of interrupt cycle. The way that interrupt is handled by the computer can be explained in flowchart as shown in figure. So this is the flowchart of interrupt cycle. You can show that here one instruction cycle or interrupt cycle. If the occupied the process will be start, then go to the instruction cycle or either interrupt cycle. If the process we can complete, go to the instruction cycle. If the problems is occupied, go to the interrupt cycle. So this is the flow of any computer for programming process, one instruction cycle and one interrupt cycle. So we can show that one explanation. Interrupt flip-flop R is included the computer. When R equal to 0, computer goes through the instruction cycle which fetch and decode the operation and final execute the phase of the instruction. We can show that here. If the interrupt cycle is handled at a time, if the process we can start at R condition flip-flop, if R equal to 0, then go to the instruction cycle. Then after, we directly go the fetch and decode the instruction. If the no problems is occupied for the any data for fetch or decoding instruction, then process will be go to the execution phase. Then after directly complete and go to the next phase. So this is one fetch and decode the instruction base R equal to 0. Now we can show the next. So the next is, if it is 0, it is indicate the program does not want to go to use the interrupt. So control the continue with the next instruction cycle. We can say that here if r equal to 0, then directly follow the instruction cycle. No interrupt is occupied. This is the process is execution process. No interrupt is occupied in instruction cycle. This go to the fetch and decode the instruction and execute and process we can complete, and this flowchart we can follow. So then if IEN equal to 1, then control the check and the flag bit. So what is the next? If the fetch and decode instruction and execute is occupied, then next is here we can occupy if the signal IEN equal to 0, then what is the go? What is the situation we can go there? The situation is I equal to 0, then one condition is process we can directly complete it and directly go to the R flip flop. If IN equal to 1, then go to the FJI number. So what is the FJI? If the both flag bit are 0, indicate the neither input or not output register are ready for the transmission of information. In case the control will be continue with the next instruction cycle if either flag is 1 where IN equal to 1 and flip flop R we can set. And end the execution phase is control the check the value of R, and if the equal to 1, then it is go to the interrupt cycle instant with instruction cycle. So we can say that if IN equal to 0, then finally execute here. If IN equal to 1, then go to the FGI flag bit. If FGI equal to 1, then process go to the R, flip flop will be increased, and finally process we can complete. Then if FGI equal to 0, then go to the FGO. FGO is 0, then process we can complete, otherwise go to the R. So this is the process of instruction cycle. If the directly R equal to 0, then go to the any number of processing. Now the next is if R equal to 1, then go to the interrupt cycle. This is the topic of interrupt cycle. If R equal to 1, then go to the interrupt cycle. Then store and return the address. It means the data we can return the storing address, and program counter is 0, and go to the branch location, find the branch location which data we can use, program counter we can increase, and IN we can 0, and register flip flop will be 0. It means the data we can send the previously of the if any problems is occupied, and finally go to the R. So this is the interrupt cycle. So this is the flow chart we can explain of interrupt cycle. If flip flop will be 0 and 1 will be interrupt cycle. So now what is the explanation of interrupt cycle in short terms with some branch difficulty or branch operation. The interrupt cycle is hardware implementation of branch and save the return address operation. The return address is available in program counter, is stored in a specific location where it is come to be found later, where the program is returned to the instruction at which is interrupt is occupied. This location may be processor register, memory stack, or specific memory location. It means if the branch instruction is occupied, that time go to the any processor register, memory stack, or any specific memory location, because the data we can store in return address. For example, suppose the interrupt is occupied R equal to 1 while the control is executing the instruction in address 255. At that time, return address we can 256 is program counter. We can show with one diagram. Here one IO device, one memory, and before the interrupt and after the interrupt. If the interrupt is occupied, that time we can store with the address 256. So we can show that here. if the memory we can directly access 25 address, then go to the 256, and finally this data we can swap. The programmer have been previously placed the input-output service program in the memory starting for the address. So this is the starting address. That time we can use this data 255. We can put here 256. So this is the next address of instruction cycle. So the programmer have previously placed the input-output in a program in a memory. So this is the use of the memory database for the swapping or any programming error. The content of program counter 256 is stored in the memory location 0. PC is set to the 1 and R will be clear. If the R here will be clear, it means the no problems is occupied. If the problems is occupied, then R go to the 1. Program counter we can increase it. At the beginning, the next instruction cycle, the instruction that is read for the memory is in the address is 1. Since that this is the content of program counter, the branch instruction at the address 1 cause the program to be transferred to the input-output services program at address 110. We can show that one short explanation here. But what is the concept here? One IO device, this address 1120 and memory programs, and this address we can store here, and here we can same. But we can use the 256 for the next interrupt. If the any problems is occupied, then directly go to the previous memory database. So this is the interrupt handling program, or you can say that interrupt cycle. How can you fetch and execute for the instruction based on the branch and program counter and location. So thank you all of you.